And we're up and running. Welcome, everybody. Thank you for coming. If you can't hear anything, you may have to turn the volume on your computer up. If you move your mouse a little bit, you should see that there's a mute mic and mute camera up at the top. I have muted some of you because there was all kinds of background noise. All you have to do to speak is unmute your mic, click on that, and speak up. And speak up at any time. Interruptions are just fine. Way up, and if you move also way to the left, on the left menu, you should see a little text icon, and if you click on that, it opens a chat window on the right. And the chat window is one option for asking me questions. And of course, you can send me a text message. All right. So the first lesson was titled, welcome, Jordan. The first text message that was shown, the first lesson is graphs and models. And I don't know, let's see if some of you or any of you have some questions on that. You work through the exercises, anything you want to ask about. I'm just going to wait a few seconds here. Anybody have any questions? Speak up. That'd be just fine. All right, then we'll get started. I'm just going to show you some important things. I know this lesson wasn't necessarily on this, but we'll be getting to this shortly. So functions are a huge part of calculus. And when you look at the beginnings of calculus and the importance, these two guys come up big. That's Leibniz on the left. He's one of the discoverers of calculus. And that's Leonhard Euler on the right. And he has a lot to do with the function concept. This shows that without him, we wouldn't have this. Well, let's see. Now, anyway, we wouldn't have this notation of functions down here. Okay, so I don't usually do this, but I'm going to show you some slides to help wrap up this section of what are functions. So the first thing we're going to deal with is what's the difference between a relation and a function. And a relation, welcome, Keenan.
The coaching classes start until after fall break.
Okay, where is Keenan?
Dude, what?
The coaching classes start until after fall break.
Yeah, Keenan, we are up and running, so if you could mute, that would be wonderful.
Can I give you like $10 in gas money, Steve?
Oh, sure. You
I'll
can
give you like $10 in gas money for your car.
Here we go.
Not today.
Keenan. There we go. Okay, we got Keenan mic shut down. Anyway, a relation is any ordered set of any set of ordered pairs, and when it comes to a function, we have some restrictions, as you can see from this next slide. A function, each value of x. Okay, we got a mic problem here. Let me just solve this again. Hi, Lexi.
Hi.
I'm going to mute your mic because there's background noise. There we go. So anyway, as I was saying, a function, when you have a value of x, can only have one value of y. That would be the equivalent of me going to the grocery store, buying a gallon of milk and being charged one amount. Then a little bit later, somebody like Lexi goes and buys the same gallon of milk and gets charged a different amount. We would never stand for that in America. And a function won't stand for that either. You cannot have two different y values for the same x. So that's a really important concept. A relation, we don't care. Anything goes. But in a function, only one answer for each given x. So that's a huge concept. This can be pictured this way. So you've got the values of x over here, and each x points to only one y. So that's what that's trying to show you. You can't have two x's or an x pointing to two different y's at the same time. Let me show you the equivalent. This would not be allowed. You can't have this going on, where you have one x going to two different y's. That's a no-no. All right. So one way I need all of you to be able to function and tell me if something's a function, is to look at a set of ordered pairs. So in part A up there, we look at those ordered pairs. And there are no repeats for x. Each x is different. -2, 0, +2, 4. Those are all different x's, so we're in the clear. That's okay. Those can be a function. As opposed to part B, that's not a function because -1 goes to 1, and then later -1 goes to -1, and that's not allowed in a function. So that's why that second one there is listed as not a function. Usually we deal with functions being the letter F, I guess because that's the word function starts with F. And then if we need an extra function, usually we just start going on in the alphabet, G, H, I. So we see a lot of F of G of X, F of X, G of X, that type of thing. Okay, now one of the great advantages of function notation is this ability to find a function at a certain value. So the f of x here is x squared minus 3x minus 1. What's f at -2? And that notation, so what we do is we literally put a -2 where the x is, and that tells you what to do. Substitute in a -2 for each x, which you've seen that they do right here. They substitute it in right there, and then we get after we calculate it out, we find out it's 9, and this is awesome because f at -2 is 9 implies that the point -2, 9 is one of the points on that function. Notation, it shows you x, y real nicely. Okay. So when we can also find f at something like x plus 2. And again, the x plus 2 has replaced the x. And that's exactly what you do for each x. We have to put an x plus 2 in, which they have done. And then, of course, you have to whack it out. X plus 2 squared, don't forget, is not x squared plus 4. There's that middle term, 4x in there. Anyway, then you gather all the terms. And again, we found it. F at x plus 2 is 4 minus x squared. And you'll hear us talk about the word domain. Find the domain of the function. The domain means try to think of, are there all the possible values of x that could be substituted in here? Is there anything you can't multiply by 3 and add 15 to? Welcome, Maria.
minus Jake when you
Try that again, Maria.
hand.
Wow, Maria, you're I'm hearing half of you. Try that one more time. Yeah, Maria, you're going to have to ask me your question in the chat. Something wrong with your audio. If you wiggle your mouse button, you'll see there's a chat button way in the top left, that blue thing. And if you click, you can then a chat window will open up, and you can put your comment or question and write it there. I'm sorry, I'm just not picking up your audio properly. And I don't know why. All right, but please don't give up. Ask me, or you can send me a text message to 262-510-2046. Okay, so anyway, is there anything you can't multiply by 3 and add 5 to? No, you can do anything there at all. And therefore, because of that, the domain, all the values of x, it can be anything. So a domain is all real numbers. Yeah, I'm getting partial audio from somebody. All right, function 10. Now, this function, the square root of x minus 3, is telling you something else. It's telling you that, I mean, x can't be anything here. I think you can... Yeah, somebody is having problems and needs to be muted. So give me just a second here. See if I can figure out who it is. Yeah, Maria's connection is goofy. We're back. All right. So we've got this f of x equals the square root of x minus 3. And you can see, I think, that you can't have x be anything here. If x was if x was 0, we have a problem. At least over the real numbers, that would give us f of x equals the square root of negative 3. And we can't, in the real numbers, take the square root. Yes, the imaginary numbers. Okay, we got a message here. My roommate is on her laptop and I'm on my iPad, and neither are loading or working right. Okay, well, I don't know what to tell you, but we'll have to talk about it tomorrow. And you can go to the video only link in the email. I sent you 2 links. The first link should have gone to this live, but if that's not working, go to the second one, which is video only, and that should work. Okay, so that's my message to Maria and her roommate. Okay, so now, as I was saying, x can't be any number, because if x was 2, we'd still have the square root of a negative, and we can't do that. So x can be 3. That gives you a legal value of square root of 0, which is a legal number, 0. So x can be 3 or anything else. So here the domain is limited. This thing down here on the bottom reads all x such that x is greater than or equal to 3. So those are the legal values. That's the domain of the function. All right. So here I have an example of a function. F of x equals 3x minus 3. What is f of negative 3? Well, we make the substitution of negative 3 for x. We plug it in. We get negative 9 minus 3, which is negative 12, which tells us, just like this shows you over here on the right, it shows that when you plug in a negative 3, out comes a negative 12. What's f of x plus 1? Again, substitute. wherever there was an x in the function, we're now going to plug in an x plus 1. Go ahead, work it out. You can see that it comes out to 3x plus 3 minus 3, which is 3x. So when you plug in an x plus 1, out comes a 3x. And lastly, I know it sounds stupid, but what is f of triangle? Plug a triangle in wherever there was an x and see what you get. And you get a 3 triangle minus 3. Okay, so this idea of substitution is very important when finding function values. Okay, we're getting voice from someone. But anyway, so let me move this over. There we go. So what's the domain of this function? X plus 2 divided by x squared minus 1. And here we have a problem. We know that denominator, yeah, somebody is talking. Who is that? Can't find it. Okay. So we know that x squared minus 1, that denominator, we know that can't be 0, right? You cannot have a denominator of 0. So what would make that denominator turn out to be 0? And the answer is either 1 or negative 1. So those can't be. So here you see at the bottom, you see a domain that's written kind of in negative. It's saying, well, x can be anything it wants except 1 or negative 1. So x cannot equal 1. Or so sometimes a domain, you know, all you got to do is list the only 2 things it can't be. And this would be a classic example of that. It's really important that you keep your eye on the domain, because you can do all kinds of horsing around in a problem, but if you're not aware of that, it could waste huge amounts of time. Okay, so now we have this concept of what's called a difference quotient. A difference quotient is a fancy name for a slope. So we got a diagram up at the top, and we've got, let's say, we've got this point right here, and we've got this point right here. And we want to find the slope of the line containing them. So in real generic terms, this is, let's call this x coordinate x, and its y coordinate would be f of x. So those are the coordinates at that point. Now we move over to the right, and let's say the bottom side of this little right triangle here is h. So this is x plus h for an x coordinate, and for the y coordinate, it's f of that, f of x plus h. So now you guys all remember how to find slope. What's the slope of that? Oh, it's y2 minus y1 over x2 minus x1. And here we have it. What's the y2? F of x plus h minus y1 f of x all over the change in x, which is x plus h minus x, h. So all this is a glorified slope formula. So that thing in the box, by the way, I have a tendency, when you have something really important that needs to be remembered, I will put it in a box. So that's very important. That's called a difference quotient. So now we're going to spend a little time finding some difference quotients. So let's show you this one. So let's take this as our function, f of x equals 2x minus 1. All right? Find the difference quotient. Well, if I'm going to do that, I know that this thing right here with the circle down here at the bottom, F, that's my difference quotient. So you need to know what f of x plus h is. So let's find out. So up here at the left, that's what we're doing. We're saying, what's f of x plus h? Well, plug in x plus h for x. 2 times the quantity x plus h minus 1. So that would be 2x plus 2h minus 1. All right, so now take that, subtract from it the original function, 2x minus 1. Notice I put it in parentheses because I want to subtract the whole thing. All right, so what happens when you, and then by the way, that's all over h. So what happens when you simplify that numerator? 2x minus 2x is gone. 2h is left. Negative 1 minus a negative 1 is gone. So we wind up with this 2h over h, which simplifies to 2. So the difference quotient for this particular function is 2. All right, not very hard with that function. Did anybody have any questions on that? So Claire, is a real number just positive or can it be negative? Real numbers can be negative. It's just that the square root of a negative, that's something different. That's imaginary. That's not in the real numbers. So, sorry, I didn't see that until just a few minutes ago. But Claire, that was your question. So, yeah, real numbers are positives, negatives, no problem. But the square root of a negative, that's not real. That's imaginary. And imaginaries are fine. We're just not going to be dealing with them at the beginning of this year. Okay. Let's take a look at this next function. So we've got x squared minus 7 is our function. Find the difference quotient. So first we have to figure out what is this f of x plus h. So we plug in an x plus h for x. We square it, subtract 7. Don't forget about that middle term. That's not just x squared plus h squared. There's that 2x, there's a doubled middle term in there. So anyway, here it is, this thing right here. So take that, subtract the original. Notice I did in parentheses again, and divide by h. Well, that numerator, the x squareds, wipe each other out. The negative 7s wipe each other out, and we have this thing left. 2xh plus h squared. And we have it over x. Well, the h can be factored out of the top. And now we've got about as good a form as we're going to get. The difference quotient on this function is 2x plus h. Anybody? Are we? Yeah. By the way, I'm okay with you guys interrupting. Just because we had a little audio problem there, and I could only get half of it. That's the only reason I shut that off. But you know, you just spout forth if you want to ask a question. All right. All right. So we did those two already. Let's take a look at a little bit longer one. Okay, so this time the function is at the top. 2x squared minus 3x plus 2. Just a little bit of a longer function. Again, find the difference quotient. So that means, you know, we got to go ahead for this thing in the box down here at the bottom, right? This f of x plus h minus f of x all over h, which you're going to memorize because you really have to know that. So I need to begin with what is f of x plus h. So you notice I've started to work that out right here at this point here. So again, plug in x plus h wherever it appears in the original function. So 2 times x plus h squared minus 3 times x plus h plus 2. So you work it out, and you come down to this thing by the green line here. 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 2. Now subtract the original function in blue. Take the and I did the vertical format here. So the cool thing is you're able to put the like terms right underneath each other. So subtract the original function in blue, and so this term wipes out. We get a 4xh plus 2h squared. The negative 3x's wipe out. You get a negative 3h, and the 2's wipe each other out. So do all of that, and you're down to this guy, or this numerator down here in the red, right here. 4xh plus 2h minus 3h all over h. And you notice you can factor out an h out of the numerator. There's an h in each term. And when you factor that out, you can cancel. And we have our difference quotient. So that's kind of the next level of a difference quotient. All right. Now there's still some more difficulties we have to deal with. We're heading there. Okay, and here's the next level. When you have a division problem, like g of x equals 1 over x squared. Okay, so remember, we're headed for this. What we want to do, and let me change to, I don't know, black here. So what we want to do is we want to find, let me undo that. We want to do g of x plus h minus g of x, the original function, all over h. That's the difference quotient. So because that's where we're headed, we need to find what g of x plus h is. So you plug in x plus h for x. That gives you 1 over x plus h squared, which is 1 over x squared plus 2xh plus h squared. All right, so now you take that, as you see down here in this blueprint, you subtract the original, and the original is that guy. This is not so simple now. So we have to subtract a fraction from a fraction, and eventually we have to put it all over h. So this becomes a more ugly, kind of uglyish little problem we have to deal with here. Okay? So let's keep going. How are we going to subtract? Well, we can't subtract those fractions until we have a common denominator. So that means I'm going to have to multiply this top fraction, top and bottom, by x squared to get this in. And I'm going to have to take this fraction and multiply top and bottom by x squared plus 2x minus h squared. So, okay, so yeah, let me just do them separately. So the first one by x squared, that'll give us x squared over, yeah, let me try, write that more neatly. I'm going to take my keyboard off so I can write a little bit better. Sorry. So x squared over, and then we're going to take x squared times x squared plus 2xh plus h squared. Okay, that's the first fraction. Now the second fraction, we're going to multiply top and bottom by x squared plus 2xh minus h squared. So the top one, 1 times that whole thing is x squared plus 2xh plus h squared. And on the bottom, we've got the same denominator, x squared times x squared plus 2xh plus h squared. And that's still all over h. Okay, so let me get rid of this thing on the bottom here because we need the space. All right, So now, continuing. What happens now that we have a common denominator of those two fractions on the top, we can literally take x squared minus that quantity, that thing in the numerator there. So x squareds are going to be gone. We're going to have a minus 2, that should be xh there, minus 2xh minus h squared, all over the common denominator. Okay, and then all of that's divided by h. So what we've got here is a fraction divided by another fraction. I mean, you could think of it as h over 1. We got and when you do that, you can invert and multiply, right? And when you invert and multiply, what's going to happen to the h? Well, the h is going to just wind up on the bottom, right? So, in other words, this is going to be h times. Okay, did everybody pull that? Get that? Let me get this out of here. We don't need that anymore. All right. So that's my problem. All right, now I can take an h out of the top. Do you see that? We can factor an h out. So this is h times the quantity, negative 2x minus h. And on the bottom, h times x squared times x squared plus 2xh plus h squared. These h's cancel. And what's left, that's your difference quotient. So the final answer, negative 2x minus h over x squared times the quantity x squared plus 2xh plus h squared. That's your difference quotient. So these fractions, that's a little bit of a chore to deal with. But I need all of you to be able, I need you all to be able to be, to be pretty quick with that, to be able to do that. All right. And then, now this one's not so different. Another fraction. I want to get to this one. Okay. So what are we going to do when we have a root? So how are we going to handle this problem? Let's change to dark blue here. All right. So we already know that we have to head for f of x plus h minus f of x all over h. And so to get started, I know we're going to have to figure out f of x plus h, and I have. I just plugged it in. All I got to do is plug in x plus h where there's an x. So that appears to be real simple. By the way, do you notice that I have already indicated the domain? You should be thinking about domain. Because x cannot be anything less than 3, I have stated that. It's got to be 3 or above. All right. So now let's do the difference quotient. Take f of x plus h minus the original f of x and put that all over h. That's my difference quotient. I can't quit when there's an h on the bottom. So we have got to be able to do some algebra to get rid of that. So we proceed. Do you remember this technique? How in the world can I get that h out from under the square root? This one right here. I got to get that out because somehow I got to get it to cancel with that h on the bottom. And the way to do it is to multiply the top and the bottom by the conjugate of the top. That is, that same thing with a plus sign between them. And of course, if I do it on the top, of course, have to do it on the bottom to keep it legal. So that's the important first step. Because what happens when I multiply those two conjugates on the top? When you multiply conjugates, you get the difference of two squares. So in other words, what I mean by that is you get, what happened, what's the square of the square root of x plus h minus 3? It's when you take the square of a square root, you get that thing. So you get x plus h minus 3 minus the square of the other part, x minus 3. Well, that's beautiful. So you notice we got rid of the roots. The bad news is we got a root on the bottom. I mean, that's not really that bad news, but we have to live with it. So let me just write it out here. So here's what we get when we do that. All right, simplifying the top, the x goes away and the minus 3 goes away, which leaves you with an h on the top. So just rewriting it, we have this. And now, very important thing happens. We get those h's canceling, and we get the final, so we get the final, let's see, I got to figure out why did my pen stop. Can't get the pen working, but anyway, we get 1 over the square root of this thing right here on the right. And all right, so that h has to cancel. So then you're wondering, well, what are we going to do with this h right here? You don't have to do anything, because the whole idea here is the last step. Here, you got it back. The last step which I'm not doing, we have not gotten to limits yet. But when we get to limits, what we're going to be doing is the limit of that whole thing is h approaches 0. Well, if this h out here is 0, we're in deep trouble, because that makes the whole denominator 0, which you can't have. But in here, it's not a problem. As h approaches 0, this is just going to be the square root of x minus 3 plus the square root of x minus 3. And it's going to be, well, let me take that back. It's going to be 1 over 2 square roots of x minus 3. I mean, but we, I mean, that, I just was showing you, really, this is, you're done right up above the line there. But, so you can't, we got to get that h canceled, which we did finally in this step right here. And that's, I mean, that's your final answer. And so that it's when that h comes out of the denominator that you're okay. Question. Just checking on my group here. Anybody have a question? So let me go back to, I think we're at the end here. Let me just remind you that we've got these core exercises, and what you guys are going to be looking at now are these in the 1.2 range. And some of the stuff I went through today is, I mean, eventually we're going to be getting to these difference quotients, and they're very important. So, somebody else have a question you want to ask? Do we need to do the trig review assignment? Eventually we will get to that. Yeah, trig is going to be important this year. Not right away, but if you you know, go back and maybe practice your ratios and your special right triangles. But that just points you to the fact that there are some links there you can click on. I mean, you can't click on this, but if you look on the calc page, on the web page, you can actually click there, and it just brings up some trig review for you. So yeah, in the scheme of things, keep up with the trig, but we will get specifically to it a little bit later. Any other questions? Okay, I think we're going to call it off. You can certainly contact me outside of class, send me text messages, emails, whatever. And I will see you. I'll see you tomorrow.